So, you're probably wondering how we got here, specifically to this mess of an egg. To answer that, let's rewind a few minutes, and I'll use my abhorrent cooking skills and general failure to do household chores to teach you more about chemistry. First up in my series of failures will be frying an egg. This is a decomposition reaction called protein denaturation. In protein denaturation, the electromagnetic heat from my induction cooker breaks down the weak chemical bond in the liquid egg's proteins. But wait, what actually happens to the proteins inside the egg? To answer that, let's rewind again. Yes, again. To give an analogy, if you can think of the proteins inside the egg as strings of yarn, it's like the whole egg itself is a messy string of yarn that starts to unfold as heat is introduced, and then later on tangles back together in a tighter, more solid mat. That is the white egg that you see. And so we get denatured proteins from folded proteins by introducing heat. Although, can you really still call this an egg? I'm sorry, I'm vegan, it's been 9 years since I last cooked an egg. Don't worry though about the environmental impact of this little experiment because my induction cooker is 90% energy efficient and it eliminates the need to use traditional gas stoves which emit gas fumes. Up next in my series of misadventures is caramelizing sugar. This is another example of thermal decomposition, much like the previous egg example we already had. The heat from the induction cooker breaks down sucrose into smaller molecules, releasing water as steam. This changes the texture and the flavor of the sugar, making it great for sweet treats, and it makes it possible to make sugar hair strands like you'll see here. Once again, the induction cooker saves the day here because its precise heat means we can avoid extra burning, which would release soot particles into the air that are harmful for the environment. So once again, this is also environmentally friendly. Finally, in this series of misadventures, let's explore this early 2010s coin. This 1 peso coin is minted with nickel. Specifically nickel-plated steel. Over time, the nickel on the surface of the coin reacts with oxygen to form nickel oxide, which makes it hard to read and look dirty. To clean it, we'll be using a double displacement reaction. By mixing vinegar or acetic acid with salt, we can form a powerful electrolyte solution. The acetic acid then swaps partners with oxide on the coin, which creates nickel acetate and water. This salt that is formed is actually soluble in liquid, and so the dirt literally starts to fall off, making it easier to read what was originally on the coin underneath the layer of oxide. For this experiment though, rather than completing the cleaning of the coin, we wanted to show you something interesting. And this is actually rooted in history. As an avid numismatist, I can tell you that early 2010s coins actually had a layer of copper under the nickel oxide. And because the acid or the acetic acid of the vinegar can seep through microscopic pores, it can eventually reach that copper layer underneath. When that copper, moisture, and CO2 from the air react, they act to form malachite, or a copper carbonate hydroxide crust. This is actually also environmentally friendly because instead of using harsh synthetic and non-biodegradable acids to clean the coin, we use biodegradable and safe materials that are also safe for drainage pipes, and by cleaning coins, we also help reduce metal waste in the environment. With that, I hope you learned something from my misadventures and see you guys in the next video.